I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.
In this video, we're going to talk about exceptions in Java. For this purpose, do import this project exception into your workspace and open up these files. We talked about compile time errors. For example, if I type in some random text, it's going to show us a compile time error. Similarly, if you're trying to assign a float value to an integer, it's going to throw us a compile time error. Compiler will not compile the program unless we fix all these errors. That being said, the ultimate job of compiler is to translate your code into a language that a JVM can understand. That means the bytecode. Compiler does not take full responsibility on fixing your errors. It will only try its best. What I mean by that is that there could be a scenario where an error could come when you run the program. That means compiler compiles the program successfully, but an error could come when we run the program. These kind of errors that come during the runtime are called exceptions. Well, the actual definition of an exception is not an error that comes in during the runtime. In fact, we're going to form our own definition of an exception after we take a look at this example. In here, I have just created an object of this class, exceptionTemp, in which I have a method that will just simply return this string. We have few instructions in here, and we know what those are. I'm calling this method and passing this object as an argument. Inside this method, I'm calling another method, method2, and I'm passing in the same object. And we're using that object to call this example method. Pretty well and good. Let's see the output first. Pretty well and good. Now, let's say I'm passing in here null. Maybe accidentally. Now let's run the program and see what's going to happen. It has executed these two lines of code, and something went wrong in here, due to which these instructions didn't get executed. So what has actually happened? Let's take a look. We're passing null here. Eventually it will end up in here. So it's going to be like this, null.example, which doesn't make sense. It has to be an object. The reason why this is called a null pointer exception is called the reference type is actually pointing to null. What do I mean by that? For example, we have a reference type object obj, and this reference type is pointing to null, and that's why this is called a null pointer exception. And this exception will only come in when we run the program. It's okay to have exceptions here and there, but it shouldn't cause the entire program to crash. In this example, these two instructions are innocent. Still, they didn't get executed. This is a big concern, especially for bigger applications. We can't expect the entire software to crash just because of one single exception behind the scenes. And there is a good reason why JVM don't execute all the subsequent instructions. That's because JVM thinks that if it executes all the subsequent instructions, there could be side effects due to the failure in this line. It makes sense from JVM perspective, but from programmer perspective, he wants all the rest of the instructions to be executed regardless of there is an exception somewhere in the middle of the code. How do we handle this? Is by using exception handling. Before we take a look at the exception handling, let us talk about something called a call stack. Whenever JVM comes across with an exception, the JVM is going to create an object of that particular exception. In this case, it's null pointer exception. And the JVM is going to throw that exception. When JVM throws that exception, there has to be something that will catch it. In this program, we don't have anything to catch it. So JVM tries to find some block of code that will catch that exception. If it doesn't find, JVM will throw that exception to the calling method, which in this case this method. And even in here, we don't have any block that will catch that exception. the JVM keeps throwing that exception, and it will eventually end up in the main method. And even in here, we don't have a catch block or a handler code, and hence JVM will just stop executing rest of the instructions, and it will just abruptly stop the program. So somehow, as a programmer, we need to convey the JVM that it's okay if you find exception. I still want to continue with the rest of my instructions. So how do we convey the same? By just looking at this program, you could make a guess that there is a possibility of getting a null pointer exception in this line. So what you're going to do is you're going to wrap this code. You could have more than one line, obviously. You can wrap this code into a block called try block. As simple as that. By doing this, you're telling the JVM that try this block of code, and within this block, if you come across with any kind of exceptions, throw that exception and I'll catch it. And the way you catch it is by using the keyword catch. And what is that exception that you're trying to catch? Is null pointer exception. And you have the handler code in here. By doing so, you're letting the JVM know that you're aware of the potential exception that's going to come in here. Now, from JVM perspective, since it's sure that you're aware of what you're doing, it won't mind executing the rest of the instructions. Now, if you run the program, everything runs smoothly despite having an exception in here. Alternatively, you can just use the IDE's facility to wrap this code inside try and catch is by going to source, surround with try catch block. Let's run the program. Pretty well and good. And you see the call stack in here. Well, that's what is an exception in general and how we basically handle it. Let's continue in our next video. Alright, let's continue. In this video, we're going to take a look at the types of exceptions. Basically, there are two categories of exceptions. We have checked exceptions and unchecked exceptions. And within the unchecked exceptions, we have a couple of more categories. There are errors and runtime exceptions. The example which we have just taken a look at, the null pointer exception, is an example of runtime exceptions. All these runtime exceptions are due to the programming error or due to bad handling of exceptions. But when it comes to errors, these are actually not within the hands of a programmer. These errors are dependent on the hardware on which you run the program. I'm not talking about the compile time errors, the syntax errors, or if I assign a value of a float to int, that's all compile time errors. These kind of errors are still exceptions. I mean, they come during the runtime. A good example of these errors could be the stack overflow error, which we looked at in our previous example. I'm going to demonstrate the same in a while. Maybe I'm just going to demonstrate and then we'll talk about the checked exceptions. So in here, I'm just going to create another method, static void new method recursion. New method recursion. We're just going to call the exact same method. And from here, we're going to call this method. Let's comment out all these lines. If you run this program, this method is going to call itself forever until the stack gets full. Now, what is the stack? We've talked about it a million times. A stack is a memory location where a dedicated section will be allocated for each method call. Let's run this program. here we have it. If you go up a little bit, we got Stack Overflow error. This method has called itself to an extent where the memory is full. Now this is dependent on the hardware on which you run. If you set the JVM parameters to utilize more memory, then this would delay the error, right? So these are called errors. Now let's talk about checked exceptions. What is a checked exception? As I've mentioned, the major job of compiler is not to fix errors in your code. Its job is to translate your code. But however, it's going to try its best to make you write a clean code. That's where the checked exceptions will come into picture. When the compiler scans your code, it's going to make a guess. Just as you have predicted that there is a possibility of null pointer exception in here, the compiler is also going to try its level best to make a guess on such exceptions. One such example of an exception is file not found exception. I'm just going to paste a line of code. Essentially, let's import that class. Essentially what this instruction is doing is we're just kind of getting a file reader so that we can read the content inside this file in the subsequent instructions. But what we're more interested in is it has thrown an error. Let's see what it says. Unhandled exception type file not found exception. So in here the compiler made a guess that there is a possibility that we get file not found exception. What that means is I have specified a path to a file. What if this file is not existed? We're going to get a file not found exception when we run the program. So compiler is kind of telling us to handle this exception because there is a possibility of file not being present in the specified location. So the programmer is forced to provide the handler for this. Only then will the compiler compile the program. Even though this file is actually present, compiler is still going to ask the programmer to handle that exception. These kind of exceptions are called checked exceptions. That's because these exceptions are checked by the compiler, not by the programmer. Hope that makes sense. So we talked about all the types of exceptions. One is the error, like Stack Overflow error. That's why it's called an error. And we've talked about runtime exception, like for example null pointer exception. And we've taken a look at the checked exceptions which are checked by the compiler, for example file not found exception, etc. We're going to take a look at a whole list of exceptions. Of course we're not going to go deep and write code for each and everything. It's not worth the time. You can experiment it on your own, but we'll definitely be covering all the popular exceptions that you would typically come across when you write Java programs. See you in my next video.
Okay, let's continue. In here I'm just calling a method inside another class, and inside that method I have a line of code that can potentially generate a file not found exception. And since it's a checked exception, I'm forced to provide the handler, and that's exactly what I did. I have wrapped the line with try catch block. Now let's say we need to do something with this argument. Say object dot example. I'm just calling this method. Now there is a potential that this line can generate a null pointer exception. So we need to wrap this code with try catch block, and we handle the null pointer exception. Why this has to be exception by default, we'll talk about it in a minute. Let's call this null pointer exception. I'll do control space to autocomplete the statement. Now this is very tedious job because for each and every line of code I write, I need to take care of providing the exception handling. Luckily in Java we have a shortcut. You can have multiple lines of code inside a single try block. What that also means is we can have a single catch block that will handle multiple exceptions. So I'll do Control X and paste it in here. We need to separate both these exceptions with the pipe character, and also we can now get rid of this variable in here because this variable will represent either of these exceptions. And this approach will be apt only when you're
providing the same handling for both these type of exceptions. Now we can get rid of this code. Or better yet, you can just have simple exception. What did I just do? All the exceptions that we're talking about, null pointer exceptions, file not found exceptions, or exception in general, are essentially class files that were created by somebody somewhere. Let me just take you to the hierarchy of all these exceptions. First of all, let me just quickly credit this website, programcreek.com. I'm able to find this diagram, which I thought will help you understand what I'm trying to say. All the blocks in blue are all unchecked exceptions, and all the boxes in red that are below this exception class are all checked exceptions. An example of which is file not found exception, which we have talked about. And an example of the runtime exception would be the null pointer exception, which is an unchecked exception. And we've talked about both of them. We've also talked about error, for example, stack overflow error. So whenever JVM comes across with stack overflow error, it's essentially creating an object of the class stack overflow error, which is the subclass of this error class. You don't see stack overflow error class in this diagram, but do take note of it. And both these classes, error and exception, are child classes of throwable class. We'll talk about this throwable class in a minute or two. So the point that I want to make here is all these exceptions that we've talked about are child classes of exception class. Now let's go back to our code. So in here, since exception is the parent class of both file not found exception and null pointer exception, it's okay to have the parent class type in here. Sometimes it's better that we let the caller method handle the exception. For example, let's say we're calling this method from here. For the sake of explanation, let's assume that this Java file is not present here. All we have is the .class file version of this Java file. We have imported that class file, and then we're trying to call the method inside it. If there is some kind of an exception in this method, we are not providing the handling. Somebody else is providing the handling. We want to deal with the exception our own way. So what is the solution that Java provides? Is the throws keyword. Let's go back here. If you get rid of the try catch block in here, we're going to get a compile time error. Compiler is yelling at you saying that please provide the handling. The way you convince the compiler that I'm not going to provide the handling, but I'll make sure that whoever is calling my method, I'm going to force them to provide the handler. So the way you convey it is by using the keyword throws, and then you will pass in the type of exceptions that are expected out of this method. One is file not found exception, and the other is null pointer exception. By doing this, even Java Virtual Machine will get convinced of the fact that whoever is calling this method must and should provide the handling for all the checked exceptions. So in here you should get an error. There we have it. Now you have two options. Either you deal with the exception by providing the handler with the try catch, or you can just use the same keyword throws to throw it to its calling method, which in this case is the main method. But this is a bad practice. You need to deal with exceptions as soon as possible. So let's handle it with the try catch block. Did you observe something? We got a couple of catch blocks. We'll talk about it at a later point of time. Now, had it been the case that we didn't have this line of code, we can easily get rid of file not found exceptions. Then, since this is not a checked exception, there is no need that the calling method needs to provide any handler at all. So what is the intent of the throws keyword? The throws keyword will not be typically be used with unchecked exceptions. They're used with either checked exceptions or user-defined exceptions. In our next video, we're going to talk about user-defined exceptions. Stay tuned. In this video, let's try to understand custom exceptions. Let's say there is a requirement wherein if the age of the user is less than 18, then you're going to have to throw an exception with some message. Let's see how it's done. You just need to simply create a class. Let's call this custom exception, whatever the name that you want to give. And in here, if you want to make this exception a checked exception, then you want to extend exception. If you want to make your class an unchecked exception, then you want to use the keyword extends runtime exception. Remember the runtime exception in the hierarchy? Let's go back. So here it is. You're creating a new class in here, somewhere in here, and this will be an unchecked exception. Now all you have to do is create a constructor of this class with string as an argument, since you wanted to show a message along with the exception. And this is a very important instruction. You're going to use the keyword super to call the super class constructor, which in this case is runtime exception, and you're going to send the same parameter. Of course, this has to be small s. Now guess what? You have just created a custom exception. Let's try to use it. So if the age of user is less than 18, then you want to create a new object of your custom exception with some message. You are under age. You're not allowed to what? Allowed to apply for driving license. Let's save the file. Let's do Ctrl+Shift+F to give the proper indentation. And since in here age is 100, we're going to be safe. Let's make this 15. Let's run the program. Now can you guess where we went wrong? I'll give you 30 seconds. Why didn't we have an exception in here? That's because we didn't throw the exception. When we had a null pointer exception or any other exception, the JVM took care of throwing the exception. But in this case, since we created the exception, it's our responsibility to throw the exception. So we're going to use the keyword called throw. Now let's run the program. And I would expect these two instructions should not be executed. Here it is. And we also see the message, you're underage, blah, blah, blah. And we also see the call stack. And in case if you want this exception to be a checked exception, then you want this class to extend the exception class. Now, if you don't provide any kind of handler, you're forced to provide some kind of handling. Let's do try catch and run the program. All the subsequent instructions should work now. Pretty well and good. Now, you might get confused between the keywords throws and throw. If you open up our example, our previous example, maybe not this. In here, I'm telling the JVM that somebody else is going to handle the exception. I'm not going to do that. But whereas in here, throw is completely different. You're throwing the exception. I think it's pretty understandable. If you're interested, you can also throw the already existing exceptions. For example, you can just throw null pointer exception on your own. In this case, JVM won't take care of it. Hope that makes sense. Let's do Control Z. One last thing which I wanted to point out is in our hierarchy we have something called Throwable Class. Only if an exception is subclass of a Throwable Class will you ever be able to throw that exception and use the keyword throws. It's as simple as that. If there is an exception that can be thrown using a throw keyword, then it has to be a child class of throwable. Hope that makes sense. See you in my next video. Earlier we had talked about the custom exceptions, but there seemed to be no real advantage with it. For example, instead of saying custom exception, I can always say exception and have it in here as well. If I run the program, you would still get the exception, but the exception in here, the name of the exception is not very descriptive. But whereas if we have our own name and when we get an exception, the name is somewhat descriptive for the user. In here, instead of saying custom exception, I could say illegal age exception in here as well, and we put this in here as well. Let's save the file. And run the program. Illegal age exception. Now this makes sense. However, it is always advisable, and actually it makes more sense, to have your own methods written in here. That will be useful for the programmer. For example, instead of letting the programmer give his own age, maybe we want to define the age somewhere in here. So public static age limit, the return type is going to be int, turn 18. Now instead of letting the user enter the age, we can tell him what is the legal age, and you can use the same class name since this is static, something of that sort. Now this is not the best example I could give, but I'm just trying to give you an idea of how you can make the most out of custom exceptions. Let's save the file and run the program. The output is as expected. Okay, moving on. Earlier we had talked about having multiple exceptions under the same catch block. This is good only when you're trying to perform a certain set of actions, no matter what exception we get. By the way, we haven't talked about error index out of bound exception. It just means that I'm trying to access an element that is not present. In here, let's say we have 6 elements in here, and I'm trying to access the 10th element. This is going to result in error index out of bound exception. Now going back, instead of having these under one catch block, you can always have them in a couple of catch blocks, each dealing with individual exception. Like so. Now that being said, at a time only one catch block will get executed. For example, if we get a null pointer exception, the controller is going to get inside this block. Similarly, if we have error index out of bound exception, the controller will get inside this block. But what if there is an exception that is neither of these? Then it's always better to have a more generalized exception. Like for example, we could have simply exception. Always do remember that the order has to be more specific exception to a more general exception. If you put this catch block on top of everything, there's a problem with this. Unreachable catch block for null pointer exception. It is already handled by the catch block for exception. That means Even if you get null pointer or array index out of bound exception, the controller will get inside this block because exception is more general, and these two exceptions are actually the child classes of the exception class. So we need to have a proper order. You can also have a try catch block inside another try block. It's called nested exception. Let me just show you what I mean. For example, let's say we get rid of the handling of null pointer exception from here, and we would like to handle right where the actual statement is. We're gonna say try catch, and then we can have the statement in here, and this is perfectly fine. We got a try catch inside another try catch block. Also, so far in our examples we've talked about the null pointer exception, but remember, prevention is always better than cure. It's always better to prevent the null pointer exception than trying to handle it once it comes. What I mean by that is, every time you anticipate a null pointer exception, it's always better to have an if condition and check to see if that object is null or not. Only if this object is not null will you want to execute this statement. Now this makes sense. See you in my next video. In this video we're going to talk about finally block. Sometimes you might want to execute set of instructions regardless of if there is an exception or not. For example, think of this scenario. Let's say you have a program, a Java program, and all we're trying to do in here is to do something with one of the local system files in your hard drive, maybe a txt file. It's not possible for the Java virtual machine to directly access these files. It needs to take help from the underlying operating system, and in order to take help from the operating system, JVM is going to use native interface and native libraries. If you remember, we've talked about native interface and native libraries when we talked about the Java virtual machine architecture. So this is where these two will come into picture. So first, JVM needs to place a request to operating system asking that it wants to do something with the local system files. Now the operating system will either reject or grant that program. The reason for this request and approval is to address one of the problems with this. For example, let's say there is another program which is trying to access the same exact file, let's say. Then we can't let two programs edit the same file. It's going to create ambiguity. Actually, it's not ideal to call two programs accessing the same file. Maybe I should call this as two processes trying to edit the same file. Think of it this way. Let's say we have two different photo editing softwares, say Photoshop and something else, and both are trying to edit the same exact file. Wouldn't that create ambiguity? So to address this problem, operating system will grant the acquisition of the system resource like file only to one process at a time. Once that process do whatever it wants to do with the file, then the operating system will grant other processes. So it's the responsibility of the Java programmer to tell the operating system that it has performed all the operations that it wants to do on that file, and now it's free for other process to take. So in here you have instructions that will edit the file, and finally you have instructions that will tell the operating system that you're done using that file. But what if there is some kind of an exception in here? Then that's going to cause a serious problem. These set of instructions will never get executed, which also means that this process acquired this resource, but it didn't free it. Now operating system will wait forever, waiting for the resource to be freed by this process, which will never happen. And so in this case, we can't use the hard drive in other processes. This is where the finally block come into picture. If we could wrap this code in finally block, then no matter if there is an exception or not in the preceding code, the instructions in the finally block will get executed anyhow. So that way we'll be able to free the resources for other processes. This is not only in case of acquiring the system resource, this is also applicable when you're trying to acquire a database connection. Now let's go back to our workbench and see how we can make use of the finally block. This is a very simple program that would generate a null pointer exception. Let's run it. Pretty well and good. Now how do we write a finally block? You just have to use the keyword finally, and within the curly braces you will have all the cleanup code that I was talking about. Maybe you would want to disconnect from database, release the system resource, etc. We're going to talk about database connections and acquiring the system resource at later point of time, but for the sake of this example, let's just simply use sysout statement. And finally block. Now even if we have an exception in here, this line of code will get executed. There it is. And even if we don't, that will get executed. Now you may ask me, if we have this statement right after the try-catch block, like so, even in that case, this instruction will get executed regardless of if there is an exception or not. For example, it's executed, and even if we have an exception, it will be executed. But there could be a case where the instructions after the catch block will never get executed. For example, let's undo those changes. Let's assume that you have all this code inside a method and you're returning out of that method by using return keyword. Then in that case, all the subsequent instructions after the try-catch block will never get executed. But the instructions in finally block will get executed. Another such case is, let's say you have an exception that is not handled. In this case, we just have null pointer exception. But what if there is arrow index out of bound exception and is not caught in here? In that case, all the subsequent instructions will never get executed, but the instructions inside the finally block will get executed. Another scenario which I could think of is, let's say you have an exception inside the catch block. The same thing will happen. Now that being said, there could be a scenario where the code inside the finally block will never get executed. For example, if you explicitly exit out of the program by using system.exit, then it's going to cause the program to stop abruptly. You may want to explore this method exit on your own. A quick Google should help. Or in case if there is an error, I mean something like a stack overflow error or something, then even in that case, the code inside the finally block will never get executed. Because anyways, the entire program is going to crash under such scenarios. So there is no real purpose of releasing the resource. Okay, pretty well and good. Now you may have confusion between the finally block and the finalize method we've talked about earlier. They both are distinct. Although the purpose of these two are almost similar, they were used in two different contexts. The finalize method will get called when the corresponding object is going to get destroyed. But whereas finally is different, it has something to do with exceptions. Hope that distinction is pretty clear. Now this will summarize the chapter on exception handling. That being said, we're going to get back and talk about all the popular exceptions that are out there in the software industry. It's just that at this point of time, we haven't yet acquired enough knowledge to be able to comfortably understand all those exceptions. So we're going to come back and go through all the list of exceptions at a later point of time. And definitely I'm not going to show an example of each and every exception. I'll just make sure that you're pretty well aware of all sorts of popular exceptions out there. Hope that makes sense. See you in my next video.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.